All right, we're exploring the product rule still. Haven't actually figured out what it is yet. Let's say you're studying a slowly growing volcanic island. Maybe you're a volcanologist. Maybe you're a biologist who's thinking about as area gets added to a landmass, how do species move in, all kinds of interesting stuff. It's a conveniently rectangular volcanic island with a length of 100 meters this way and a width of 200 meters that way. And you know that it's growing at 5 meters per year this way and 3 meters per year that way. What would you say is the area at any one particular time? That would depend on the length and the width at that time, right? So we could say it's L of t times W of t, just simple, straightforward rectangular area. And what are the units of that? Well, length is in meters, width is in meters, so it would be square meters. Makes sense for an area. What about A prime? What's the rate of change of area? Well, just on the previous page, we said we'd hope that A prime of t would be the product of the two derivatives. We know that doesn't work out, but let's look at another reason why it doesn't work out. We said we'd hope that it's L prime of t times W prime of t. What are the units? What are the units of L prime of t? It's how fast L is changing per year. So it would be meters per year. W prime, also how fast width is changing per year. So it would be meters squared per year squared. That's our hope. But what should the units of A prime be? What units should A prime really have? A prime is an area measured in square meters. And if we're asking how much does it change per year, what's the rate of change per year, it should be square meters per year. So not only does our hope of the product of the derivative of a product being the product of a derivative not work out like we saw on the other page with polynomials, it doesn't even work out with the units. So we got to think harder. Anytime I hear the words think harder, I think spreadsheet. Maybe you do, maybe you don't. But let's try laying it out as a spreadsheet. So let's say in the year 2018, the length was 100, the width was 200, oh, not 2000. In 2019, what would the length be? Well, we know that L prime, how much is the width changing? It's 5 meters per year. So it would be the previous value plus 5 meters per year times a 1 year time span, so that would be 105. W prime was 3, so it would be 200 plus 3 times a 1 year time span, so 203. And then how about the area? What's the area in 2018? It's just 100 times 200, right? So that's 20,000. What's the area in 2019? I did the multiplication separately, and I get 21,315. So what can we say about A prime here, at least from this data set? How can we compute A prime based on the numbers we have? Well, we've got an old and a new value for A, so we can use the forward difference quotient. So we can just say 21,315 minus 20,000 divided by 2019 minus 2018. And that turns out to be, let's try it again, 1315 square meters per year. Notice the top is in meters squared, the bottom is in years, so I do get square meters per year. All right, so let's go figure out how I could have predicted that 1315 square meters per year based on the geometry of the problem. Let's say we have our box and we start out at 100 and 200. And then after a year, what does the island look like? Well, I've added some area up here, and I've added some area over here. This is an extra 5 meters, this is an extra 3 meters. So what's my new area? Well, this new area would be 5 times 200. This new area would be 3 times 100. It's a width of 3 and a length of 100. And in some sense, we've got this little area here, but compared to what else is going on, that's a tiny area. So I'm going to say let's ignore it. If you want to quiz me about that, we can talk about it some other time. But for now, let's ignore it. So what's my new total area? You could say it's 5 times 200 plus 3 times 100. And if you do that multiplication, you get 1300, which is pretty darn close to 1315. You might notice that this tiny area is 3 times 5, which gives you the 15, but we're going to ignore that for now. Let's think about what these numbers come from. The 5, the 200, the 3, the 100. Where else have I seen those numbers? Look somewhere on the page. So you might have noticed the 5 is L prime, the 200 is W, and the 3 is W prime, and the 100 is L. So we're saying the rate of change is not just the product of L prime and W prime or something like that. It's L prime times W plus W prime times L. Let's think about the units here. L prime is in meters per year, W is in meters, W prime is meters per year, L is in meters. Altogether we get meters squared per year. And so the units work out on this formula in a way they didn't work out with what we hoped was the nice simple formula. So now we can write the product rule based on this idea. So this is the product rule for derivatives. F times g prime equals, well, we've basically got two functions going on here, length and width. So we could call those f and g. So we could say it's f prime times g plus g prime times f. That's a good way to write it if you like always doing the prime first. Or, since you can multiply in either order, you could rewrite it as f prime times g plus f times g prime. And I actually like that version better because it maintains the order of the multiplication that we already had here. It doesn't make a difference in Calc 1. If you get to Calc 3 and you're dealing with things where multiplying in different orders makes a difference with matrices, then it's important to keep it straight. So I prefer this version, but you can use either one you want. Different books use different versions. Let's practice it real quick. Back to our original example, x cubed x to the 5th prime. Notice I've already got it written out nicely here, so I can just copy everything in columns. So take a sec to write it all out based on f being x cubed and g being x to the 5th. Okay, hopefully you paused the video and did it all, and now you're just here to check. So this would be x cubed prime times x to the 5th plus x cubed times x to the 5th prime. X cubed prime is 3x squared times x to the 5th. X cubed, we copy, x to the 5th is 5x to the 4th. And usually I don't want to simplify, but in this case I will. This is 3x to the 7th. This is 5x to the 3 plus 4, which is 7. So altogether we get, we can group like terms here, we get 8x to the 7th, which is what we saw on the other page is actually the derivative of x to the 8th here. So our product rule worked out. Phew!